There's so many ways to talk about the multidisciplinary by adding medicine to engineering, which we're doing here in the college, robotics and biology and astronomy, ocean sciences. But what I want to do, because the field is so broad, is just talk about one project that I've been involved in, and Justin has been involved in since he was a freshman year. And that's the area of something that we call small satellites. And the way that I like to think of it is back in the 1950s, we had computers that would fill this whole room. And pretty soon people started thinking that maybe if we took that functionality and spread it across a network of small PCs, we could have a lot more flexibility, economics of scale, and so forth. So you saw what happened with the PC revolution in the 70s and 80s. So we're doing the same thing with satellites right now. In 2007, China, and in 2008, the US demonstrated that they could take a land-based missile and destroy an orbiting satellite. So that leaves all assets at risk in the sky. So again, what we're trying to do is make small satellites that can fit in your hand that have the same functionality. So it's like this. iPhone has GPS, it has a camera, it has all kinds of sensors that can be attached to it, and it's programmable by software, and you can communicate with your friends as well. All of those things and more the satellites can do up in space and reach a lot more people. What we have is a crawl, walk, run, fly educational paradigm. We believe that you have to be able to walk, crawl before you can walk, before you can run, before you can fly. So at the crawl stage, we involve high school students. They build small packages, which we call payloads in the satellite lingo. And they go over a weather balloon. This one we launched over Hawaii Kai. The idea being that if there was some disaster and you have to rapidly assess what the scope of that disaster is, and you could rapidly launch a camera with a transmitter on this kind of balloon. It only takes a few weeks to build it. In fact, when Justin was a master's student, he helped a couple of juniors in high school build this within a few weeks. The next stage is what we call a CubeSat. This is about the size of a Kleenex box. And if you go to the supermarket next month, the February issue of the Scientific American will have a 5-page article on CubeSats. So to make the Scientific American is a pretty impressive subject. And I'm going to be giving more slides on that. At the fly stage, we have something a little bit bigger on the order of a microwave oven. It takes about 1 to 2 years to build. And I haven't even told my dean this yet. So I wanted to issue a press release first, so just keep it quiet, don't talk to the reporters. But my students just completed a 2-year nanosatellite project, and they took 3rd place in the nation, beating schools like MIT and these are probably your former students. Next slide, I'm going to talk a little bit more about BalloonSat. We've had a number of high school juniors that participate in our College of Engineering internship program. Last year we had a record number, about 50 students that spent 6 weeks in various labs working with professors on their research. Our students came from these different schools. They attached a camera and a stabilization system and a transmitter on a balloon that was launched over Hawaii Kai, and we retrieved the data with a station that was in the back of a roving truck. Sometimes these balloons can get up as high as 100,000 feet, and jet airliners cruise at 30,000. So you can see that this is more than 3 times the size, and you can even see the curvature of space and the blackness. So that really gets our kids excited, and we've had a number of students at the junior high level that said, I definitely want to go to engineering, and I definitely want to do it at UH. Next slide. So at the CubeSat level, they Kay Joanne sent a reporter over here, and I'm going to let them talk about it.
They're hoping to launch a satellite into space next year. As Kirk Fernandez reports, it's a unique opportunity for undergraduates.
It's called the Cube Satellite. At just a little more than 2 pounds, it represents the growing trend toward the use of smaller satellites in space. The UH project is in its early design phase, but is giving more than 50 undergraduates a chance to experiment outside the classroom.
Some other colleges have similar satellite programs, but it's mostly graduate students. It is a real-world project. You have a lot of problems that arise in real-world design that you don't in theoretical simulations or things you do in class.
This project is really more about getting a satellite into space than making any specific scientific discovery. Still, the CubeSat will have an onboard camera and sensors.
It's only, I think, 10 by 10 by 10 centimeters big. And there's a lot of things that have to go into there: batteries, solar cells, computer boards.
Getting a satellite into space isn't easy, but getting a tiny satellite into space is a whole lot cheaper.
A small satellite is great because it allows us to build a satellite very quickly and to just get it up there and see it before we graduate.
3 by 14 on project and 22 by 22.
But students will have to raise money to pay for the $120,000 project. They're still $70,000 short of their goal. Reporting from the University of Hawaii at Manoa, Kirk Fernandez, Channel 2 News.
More than a half-century.
Eventually did raise that extra $70,000 and did launch our satellite in 2006. Unfortunately, it was aboard a Russian rocket that's normally very reliable, but for the first time in 10 years it crashed. All 50 satellites aboard crashed. Also, another piece that I didn't tell my dean yet. So while we were in Albuquerque this past Monday on Martin Luther Day, we were notified that we will get an additional $110,000 from the Air Force to build another satellite. So when you visit my lab later on in the morning, you'll see this. So I'll go over this very quickly. If you could just press the button. This is just an animation of one of the satellites that we built right around the time of Hurricane Katrina and the Southeast Asian tsunamis. The idea was to build a satellite within a period of 9 months, so this would be rapidly built, and you just have them on a shelf. So whenever some kind of disaster happens, you could put this up in space. So it had a camera, GPS, this is the batteries, computer board, a radio transmitter, all fit within a box that one of our mechanical engineers built. So even though I come from the electrical engineering department, again, what we're doing is at the freshman level, we're trying to let them see the whole big picture first, and that involves mechanical engineering, electrical engineering. Sometimes they have biological experiments, so we need to involve the biologists. These are also used for predicting earthquakes based on the different waves that are produced, so we involve geologists as well. But that's not all. Next slide. We even had an 8th grader that built his own CubeSat. And this is remarkable, given that it takes 20 of my undergraduates to build one in 1 year. This 8th grader built it over a period of a few months for his science fair project. So I think he's going to be featured in that Scientific American article. Next slide, please. Just some of the outcomes that we've had. I started the program 10 years ago. We trained over 200 students. It's not that common for our students to go for their PhDs, but 9 have gone on for that, and I've lost count at how many have gone for their masters. Pretty impressive is that there's an Electrical Engineering Honor Society nationwide. They choose a most outstanding EE student in the nation every year, so we won that award in 2001, 3, and 5, and an honorable mention in 2007. Our students have written a number of papers, gotten something patented. They themselves helped to get the money to fund these projects, over $1 million so far. And they end up at some of the big aerospace companies on the mainland, as well as high-tech companies here. So this is my last slide, just 4 success stories. Aaron was one of the guys that was talking in the KHOM news spot, and he was the leader of our program as a junior. Well, he eventually got his PhD at Berkeley. He won over $100,000 from the National Science Foundation to fund his research. Very impressive. And he was one of the students that got that most outstanding student in the nation in 2003. And he's a faculty member now, so he's teaching our students. Lang Murakami was from Mililani High School, won that same award in 2005 and founded his own company, which lasted for 5 years before it fell. Next is Jason Akabi, who worked at a number of companies. He's the one that started our BalloonSat program. And for the operationally responsive space office, he built a satellite payload within 45 days, which was a record in that age. And then Justin is sitting there. He was a freshman in this picture, but since then he has gotten his master's. He's helped me get over $500,000 in funding just by writing proposals. Just putting on these great workshops. So, thank you very much. I'm going to be available at the lab tours to answer any technical questions.